All right, 5.8, we're doing all trig derivatives with and without chain rule. So we've only learned the derivative for sine and cosine. Now I'm going to give the other ones to you. Derivative of tangent is secant squared of x. Derivative of cosecant is negative cosecant times cotangent of x. Derivative of secant is secant times tangent. And derivative of cotangent is negative cosecant squared. Something that kind of helps me is any trig function that starts with a c is negative. So I don't know if you noticed that or not, but you'll get to where I definitely can remember this one. These, little iffy, I can kind of remember that one. But there are patterns to them. I can do the proofs, but I'm not going to. All right, number 1, y equals -3 secant of x. We want to find the derivative. So let's find derivative of secant is secant tangent. And so there's no negative in this. So we'll have to have -3 times secant of x, tangent of x. That one's really easy. Okay, number 2, negative cotangent of x. What is the derivative? So find cotangent. It is a negative, so we would have to take this negative times this negative as a positive, cosecant squared of x. That one was really easy. Number 3 is a chain rule because I have an inner part that's not just x. And so cosecant, that derivative's a negative, so that'd be -3 cosecant x. Ooh, not even x. I need to keep steady the inside. So every time I see an x, I'm actually going to fill in the 2x. 2x. Cotangent. 2x. Then I need times the derivative of the inside. Do not forget that part. So derivative of 2x is simply 2. So I would probably rewrite that and say that's -3 times 2 is -6. Cosecant of 2x, cotangent of 2x. And number 4. I'm going to rewrite this to where it's 3 times tangent of x to the 4th power. So we have a chain rule here. I'll have to take 4 times 3, which is 12 tangent of x to the 3rd power. I can put it here. And then times the inner part is tangent of x, which is secant squared of just x, because there was nothing inside I had to keep. So yeah, I would just leave it like that. And that's it.